Using this kind of mechanism, you can actually cure all of our diseases like myopia, hypermetropia, all diseases actually can be cured. So we have to follow this kind of rules. If you become a doctor, you can actually able to do that. Okay, this is the end of our class. We will meet you in the next video. Till then, bye-bye. What? You are still here? What? You are still here? Why? This class is ended here. See, these kind of things are actually going to happen if you skip my videos. Okay, so don't try to skip this, because see, once you skip these videos, what is going to happen? You are not going to understand things in a proper way. You are going to get some misinformation, wrong information if you just skip my video. So just watch my videos properly, okay, and do not skip it here. I'm just making for you these videos, right? So watch these videos properly and you will be able to understand the whole concept about anything, okay, about related any science like biology, chemistry, physics. Lots of things are like that. So let's start from the beginning. Hello everyone, how are you? I hope you all are doing great. By the way, welcome to my YouTube channel, Physician in a Nutshell. If you're just new to this channel, subscribe to my channel. And if you just like my way of teaching, just hit the like button and just press that bell icon too. You will get all my notifications of my videos. Okay. Now just let's start the class. In the last part 9 of that class, last lesson, that is nothing but the light reflection and refraction, we have understand lots of concepts related to light. First, we have studied what is actually light is, right? How light behaves, okay? Then we just move towards our two main phenomena. That is, one is nothing but reflection, other is nothing but the refraction. Then we got the image construction by the mirrors using the reflection phenomena, right? Again, then we move towards the image formation by the lenses using the refraction phenomena, right? Again, we got the images, right? Depending on the various positions of the object. That means that images we are going to get will be vary with the distances of the object from the lenses or the mirrors or the object position. Okay, as the object position is going to change, that image's position is going to change, right? Now, you may think that why I am just talking this or just saying this, because today we are just about to start a new lesson, right? Why I am just saying this kind of things? The last lesson we have just discussed, it is completely over. But the thing is, you may know that we are just dealing with science, and physics has that much ability that what you have got in theoretically, you can actually apply it to. In today's lesson that we are going to discuss is nothing but where we are just going to apply those kind of things that we have got in the last lesson, that light. That means what? We are going to use that concept of light in actually producing image with some kind of other instruments or by ourselves too. Okay. Do you know that camera you actually use now? I told you in my last more videos that we just use camera where the all kind of aperture that I mentioned, that focal length I mentioned, all these things are actually used in cameras. Okay. By the way, do you know one thing? In our human being, okay, not only human being, in some animals, birds, lots of that things are there, or the animals and birds and human, including us humans, they have some kind of in our body that can actually construct image, right? You know that what that thing can be actually, right? Since now you're watching the video, why and how? That why is because we have eyes. Our human eye actually acts as a lens, okay? That lens actually forms the image using the refraction phenomenon. Always remember, since I am telling that our eye behave like a lens, and lens always deals with refraction, not reflection. Okay, that means what we can say that our lens or our eye is going to work as a lens, and that lens is going to behave with the help of that refraction. It is going to show the phenomena related with refraction. Clear? Okay. Now, we will now understand using that refraction phenomena that depending on the position of the object that is placed at a certain amount of least distance or at a place at a far point, how we are going to get the images. Okay. In this lesson, we are going to discuss all these things. How actually light help us, okay, using the human eye, how we are going to observe this whole beautiful in our colorful universe. Okay, this is the main reason. So what we can actually say that our lesson is going to be nothing but human eye and colorful world. To start this lesson, okay, first we have to actually introduce ourselves to that human eye, okay, that human eye. The human eye, okay. I'm just showing you here the figure or the proper human eye, okay. Human eye actually behaves like a camera. Simple fact, okay. See, in case of camera, what actually happens? There's lenses too. Those who actually like to use cameras or DSLR cameras, they may know that in kinds of camera, in any kind of cameras, there are lenses. Okay, if you buy a camera, you're going to get some kind of kit lenses. That means having some kind of focal length from 15 to 55 mm, then you're going to get some 80 mm to 270 mm. Lots of ranges are there in case of lenses. And each lens having some kind of actually what? Different kind of focal lengths, different kind of apertures are there. Okay. We have also got that term aperture. We have also heard that term focal length, how they actually behave, right? In case of the human eye, it also acts like that. We are going to understand it step by step. You don't just worry about that. You will understand that yes, sir said that thing, that yes, human eye actually behave like a camera. Fact. Again, that human eye is mainly deals with that retina. Okay. See, whenever a light enters, the image forms on the retina. That means that retina is a light sensitive thing. What does it mean by light sensitive thing? Light sensitive means things that whenever a light falls on that retina, you are going to only observe images, not by other things. That means, see, whenever you just enter a dark room, what is going to happen? You are not going to observe anything. Okay, if you become able to observe something, it is kind of blurry image, right? Simple fact. So what we can say that retina is quite light sensitive. Okay. Again, outside retina, there's some kind of layer that we are actually observing that. That layer is nothing but the cornea. Okay, that cornea actually forms an outer layer, okay, to that eyeball. Now, what is eyeball? Our eyeball is some kind of a spherical shape. Okay, though it is kind of spherical, it's going to have some kind of diameter too. And what is the diameter? That diameter is nothing but 2.3 centimeter. Okay, again, I told you that our eye is also acts like a lens. Okay, and we name that lens as nothing but the crystalline lenses. Okay. Just name them crystalline lenses, and there is going to be some kind of refraction, and then refraction is mainly occurs in some outer layer of the cornea. Okay, so this is the main fact. Again, I told you now that our actually eye behave like a camera. Okay, what actually happens in case of camera? You can actually manage that aperture, manage that focal length. You can actually vary that focal length from certain range to other range. That means from 15 to 25, then 25 to further ranges. You can actually vary in case of camera that focal length. Again, our eye have that capacity to vary that focal length. Okay, when we will discuss some other topics, then we're going to discuss how we can our eye actually able to vary that thing. Okay, do you know what is the aperture do? Okay, I mentioned that thing in case of mirrors too, in case of lenses too. Aperture is doesn't extra thing. Aperture is nothing but what? It is the main exposed part, right, towards the incoming rays. So again, eyes have that much of aperture. Okay, so that aperture in case of the human eye is actually balanced by one term, that is nothing but the iris. Pupil is the main part through which the light actually enters. So with the help of the iris, we can actually control the amount of light that is going to enter and going to fall on the retina. See, if some of the high rays are coming, then what will the pupil do? That pupil will going to make that hole through which the actual light going to enter become smaller. And if you get in a dark room, that pupil is going to do what is going to do that is going to make the hole bigger. That is the how actually image is going to form in the retina. Again, our retina is going actually having billions of sensitive cells. When light falls on it, it actually sends the that signals that you are going to get in our retina, and those cells actually quite light sensitive. Okay, and light sensitive means when the light which is going to fall on that retina, they will actually transmit that signals through optic nerve to our brain. And our brain is nothing but a what kind of CPU in our human being. That human brain is going to decode that actually signals to some information. Then we will be able to know that yes, we are getting some kind of image. See how fast it is. Once I just close my eye, if I open, I'm going to see something. It means see how fast it is. Okay, that's how our eye actually behave. Right now, again, I told you now, lots of things are there or lots of parts are there. You are now able to see in this figure. Lots of parts are like vitreous humor, pupil, iris, right? Lots of terms are there. Okay, lots of hard terms are there. Cornea. Okay, right? Lots of terms are there. If one of the functional thing get damaged in our human being, what is going to happen? You are not being able to observe the figure or observe anything clearly. I am not saying that you are not going to see anything. Okay, you are going to get to see, but you are going to have some kind of blurry images. Okay, see, take one example. Okay, if you are standing in a road, okay, maybe in night, if a car comes and throw a high lamp, okay, high beam on your eye, what is going to happen? You're going to do like that, right? That means what? You are just protecting your eyes from that high beam. But the thing is, before you do like that, your iris, right? You are going to have an iris. I told you, okay, that iris behave like a door to incoming rays. Okay, what we can do? We can just actually open and close our doors by ourselves, and on our own, right? How much we want, we can actually open and close that door. So our iris behave like that. Okay, but it is a limit. Okay, we can open our door to a certain limit. Okay, again, we can also close that door to a certain limit. All the things have some kind of limits, and iris have a certain kind of limits. We are going to get that. Don't worry about that. But our iris is going to do what? They will actually make the hole small. Then small amount of ray is going to come to your main retina, where you're going to get some of the images, right? But what is actually going to happen? For some time, you are going to damage your eyes, those sense organs, little bit. That's why what actually happens when you just come in a dark room, as soon as that thing that actually happens to your eye, that means once that high beam fall on your eye, if you just come in a dark room, what is going to happen? You are not going to observe anything. But after some time, okay, when you just get adjust to that surrounding, to that dim surrounding where the light is a little bit low, then you will be now just clearly observe those things. It is not actually permanent effect. Okay, this is not a permanent effect. It will last for a little bit time. Okay, once you just get adjust to that second surrounding, it's going to be okay with again. But if anyhow, okay, one of these sensors get damaged very badly, okay, it is going to impact on your life or impact on your eyes, okay, on a long-term basis. Again, we are going to discuss that. Lots of defects are there in our eyes, okay, like myopia, hypermetropia, presbyopia, lots of things are there. We're going to discuss. Don't worry about that. We will going to move it or move through it slowly. Okay, see, I can discuss lots of the things. Okay, many students ask me that why sir you are making lots of parts of this video. See, I can make a single video on a certain topic. But what is going to happen? I have to discuss lots of things in small amount of time. That means what? I have to give small amount of time to every object or every topic. Right now, if I make some more videos on a certain topic, what is going to happen? You are going to get, or I will be able to give lots of times to a certain topic. Then what is going to happen? I will be very much actually helpful for that, because I will be able to actually explain the things in a wide manner. Right now, this is the main fact. So don't worry about that and don't feel bad for that. Just cooperate with me. Okay, this is the main fact. Now we have actually understood how eyes work, right? And we have actually understand that our eye is kind of a camera, right? Again, this is the main fact about the human eye. You have actually understood that. Now we'll move to our next topic. What is this next topic? Okay, before moving to that, I just need to give you some information. What information is? Our retina, okay, is kind of a jelly-like structure. Okay, it has some kind of fibers too, a fibrous structure. There's some kind of mixtures are there like that. So this is kind of fibrous type structure. Again, what actually happens in case of our retina, it has the ability to actually manage or to modify its focal length. How it can actually manage its focal length? See, whenever we actually discuss lenses, it is not like that you are going to get the lenses of equal focal lengths, okay, and we are not able to change our eye lenses quite easily. Okay, we are going to have only one eye lens in each eye. That means we are going to have two lenses, permanent lens and fixed lenses in our eyes. So what is going to happen? Then necessarily who created us gave us that much ability to our eyes that we can change our focal length by our eyes itself. Okay, we don't need other things to do it. Okay, if your eyes is normal eye, if it has no kind of actually defects. Okay, if you have some kind of defects in your eye, then it is maybe different thing. Then you have to use some extra instruments like spectacles, lenses, lots of things are actually there. We'll move towards that. Don't worry about that. Okay, see what actually happens. I told you now that our eye have a capacity to actually manage, okay, to modify that focal length. Okay, why the focal length is needed? See, to inform images, focal lengths are always necessary. Since I told you that our eye having a lens and that lens is nothing but a convex lens. Okay, in case of convex lens, what happens? The image forms at the focal length. Right now, depending on the distances, okay, if the image is coming from a distance object or the rays are coming from a very much distance object, it is going to form, okay, that lens is going to have a high amount of focal length. Okay, if the rays are coming from a short amount of distance, its focal length is going to have a shorter distance. Okay, this will behave like that. Or I have that much ability to actually manage that focal length because all the image would form at different focal objects right now, at focal points. So our eye should have that much of capacity to manage that focal length right now. So that is ability actually maintained by one muscle. That muscle is nothing but ciliary muscle. If we actually contract or relax that ciliary muscle, okay, that depending on that contraction and relaxation, our focal length is going to vary. Okay, whenever we actually relax our ciliary muscle, what is going to happen? That our lens, okay, what is going to what? Getting less amount of curvature. Right now, see, if it is a lens, right? If it is a lens, if I relax it, what is going to happen? Its curvature is going to decrease, right? Its curvature is going to decrease. That means what? If it is a lens, we are considering one more lens. What is going to happen? It is having high amount of curvature compared to this. Okay. If the lens become getting actually curvature is become less, what is going to be? That lens become a what? Thin lens. Okay. This lens is having high amount of curvature. That means what? It becomes a what? Thickness becomes high in this case, right? It becomes a thick lens and it becomes a thin lens. Once that lens become thick or thin, right? Its focal length is going to vary like that. For a thin lens, okay, focal length is higher compared to this thick lens. Okay, that means when we actually relax our ciliary muscle, what is going to happen? Our lens become going to thin. Okay, and along with that, our focal length is going to be what? Increase. Okay, and it enables us to see that distance objects, which are actually that objects which are at a very distant. It enables us to do that. Simple fact. Now, if anyhow, okay, we can actually contract, okay, that ciliary muscle, what is going to happen? We are going to get a high amount of curvature in our lens. Okay, once it get high amount of curvature in our lenses, what is going to happen? That lens is going to be what? Thick. Right now, once it get thicker, what is going to happen? Is focal length or the position where the actual image is going to form. That is not very focus, right? That focal point or the focus point is going to be what? Short. That means what? Its focal length is going to be short. And that helps us to observe some that nearby objects. That ability of our eye lens, okay, that also known as the crystalline lens, okay, is basically known as the power of accommodation. Now, you may think why the name has given us power of accommodation. Okay, accommodation means some ability. Okay, ability to actually store something like that. What we are going to, our eyes is going to store the images or that light rays, okay, after getting refracted, it is going to store at the retina. Then what is going to happen? We are going to see objects. Simple fact, right? So, why this name is given as power? See, in the last class, light reflection and refraction, the refraction part, we got the one term, power. That power is completely related with focal length. And how it is related? Power P is actually denoted by P and is related with focal length inversely. That means there is a certain relation of the focal length with the power. Right now? Doesn't matter what is the relation, but there is having some kind of relation, right? So that's why that power actually comes, because our eye lens actually behaves according to the focal length. Okay, our eye lens having a capacity, okay, is inbuilt capacity. Okay, some other parts it actually comes. It has its own inbuilt capacity to actually manage or modify that focal length, and that modification of that focal length to maintain that focal length to short and long. Okay, this is a kind of ability, right? So this ability of actually modification of that focal length is known as what? Power of accommodation. Okay, so our next topic is nothing but what? What? Simple. Power of what? Accommodation. Okay, power of accommodation. This is our next topic, power of accommodation. But the thing is, though our eye lens having a capacity to actually change that focal length or modify that focal length right now, it has a limit. Always think that this has a limit. And what actually happens, nothing is actually perfect. Okay, we can't say that something is perfect. No, nothing is perfect. And nothing is highly 100% efficient. You are going to get in maybe higher secondary that one theorem, Carnot theorem. What actually says that nothing is 100% efficient. You're going to get that. It is actually scientifically proven, not actually psychologically said thing. It is scientifically proven that nothing is actually 100% perfect or effective. Okay, so I told you now that iris actually behave like a door, right? You can actually open a door or close a door to a certain limit. We have a certain boundaries too. As like that, our human eye lens having some kind of boundaries. Okay, it can change the focal length to a certain amount of distance. Okay, so there is a certain limit. Okay, certain distance to which actually we can actually observe something distinctly. See, I'm going to take one example. Okay, this is my hand, right? If I close my hand or again hold my hand here, what is going to happen? You are now watching the video, right? Do one thing. Along with me, you just do same thing. Just hold your hand in this distance. What is going to actually happen? You are going to observe your hand and you are going to see your hand. You are just able to see your hands, but the image of your hand in your eye is going to be some kind of blurry images. So that means what? This is not the actually required amount of distance or the proper distance that you should keep your hand to get the distinct image. Right now, That means there is certain least amount of distance, right? There is certain minimum amount of distance to which the focal length should be, or to which the object should be placed, so that your image is going to be so much distinct in your retina. Okay, that minimum distance where that actually object should be positioned is known as the least distance of object vision or distinct vision. Okay, least distance of distinct vision. Okay, that means that is the least position, or that is the least distance where you should keep the object for a normal vision eye. Okay, for normal people who is having no kind of defects in their eyes, for that kind of persons, that distance should be 25 cm. That means this must be the distance of that object. Then you are going to be able to actually get the image properly, or distinct image. No blurry images right there. Proper image, right? This is the fact. Okay. And for normal people, that distance is nothing but the 25 cm. Clear? And to maintain that distance, okay, to actually construct the image which is placed at 25 cm, our eye actually behave like that. To get the image, what we have to do? Okay, what we have to do? We have to just what? Contract or relax that eye. Okay, along with that, what is going to happen? Our focal length is going to vary. I told you that. The main muscle is nothing but what? Ciliary muscles. If we just contract and relax that muscle, according to that, our focal length is going to vary. We have actually got it. Now, what about the far object? Okay, we have now got the least distance. That is the minimum distance where the object should be placed. Now, what about the far distance? Okay, till where you can actually observe things. In book, it is written that for a normal vision eye, okay, which is having no kind of defects in their eye, that far object should be placed between 25 cm. 25 cm is what? That's the minimum distance where should the actually object be placed. Okay, that far distance should be 25 cm to what? Infinity. It is written in a book. But I have some kind of doubts in that concept. Say, though it is written in a book, and again you have to write this in your exam, that far distance should be between 25 cm to infinity. Okay, this is a theoretical thing, but practical tell me one thing. We did one practical, right? That when you actually place our hand here, what is going to happen? We are not going to get the distinct image. Obviously, right? But tell me one thing, if you are just standing in a road, straight road, okay, one car is actually coming. We are just observing that one car is actually coming, right? And if that car is almost 600 to 7 meters away, okay, you will be only able to say that yes, some car is actually coming. But can you tell me which car it is? One example. Similar condition you can consider. If a human is coming, if a person is actually coming from that direction, which is again having or actually almost 5 to 600 meters away from you, you can say that one person is actually coming. Can you say that who is that guy? Is he known to you or not? You can't say, because you are not getting the proper distinct image. Okay, you can't say how many eyes that guy is having. Okay, what is the color of his hair? You can't say that. You will only be able to say those things when you are going to get a proper distinct image. So tell me one thing, how that distance should be between far 25 cm to infinity. According to me, that distance for a normal vision eye, okay, normal people who is having no kind of defects in his eye, that distance according to me, okay, I'm not saying that you should actually think like that. Okay, you can give me your own opinion too. It is quite free, right? You can also give me your own opinion. According to me, or according to my opinion, that far point distance should be between 25 cm to almost 200 to 230 meter. 200 to 230 meter, where you can just able to see someone distinct manner. Okay, but sometimes what actually happens, okay, for a normal vision eye, that distance also decreases. That means 200 meter is actually almost, you can say that distance will be between 25 cm to 200 cm. Okay, I don't think actually it is practically possible to see something which is at infinity. Okay, you can't actually say that. You can actually kind of what? Theoretical thing to do. So this is the fact. So again, it is not actually that you have to actually follow it. I am just giving my own opinion. You can give me your own opinion too in the comment section. Just give me your own opinion in the comment section what you thought actually. If I am, maybe there's a possibility I may also be wrong. Just correct me if I am just wrong, okay? But I am just thinking it practically. See, whenever you just place your hand, okay, you are just observing your hand, you are getting an image. That is nothing but a blurry image. But once you put the object in 25 cm from you or from your eye, you are going to get a distinct image. So same thing should be happen in case of the far distance too, right? If you place an object at infinity, tell me one thing, that if you just you place a human being at infinity, you don't know where is the infinity. Okay, I just consider that you just place someone at 1 kilometer distance from you. Okay, you will be just able to see that yes, someone is there. You know who is that guy? It's obviously not, na? But the thing is, whatever I say, whatever anyone say, you have to write what is actually in your book. You have to write that the far distance should be between 25 centimeter to what? Infinity. This you have to write that. Okay. I'm just giving my own opinion. You can also give your own opinion too in my comment section. Just give me your own opinion. I need that. Okay. Just feel free to do that. Okay. We have actually got it. Now, see. Some defects we have also got that where I told you in the earlier part that whenever our some important parts of our eye got damaged, what actually happens? Our eye is not become able to form the distinct images. But sometimes what actually happens? Something happens necessarily in case of old people. When people becomes old, what actually happens? Their muscles, which is necessary or which is actually main thing to actually contract the eye lenses, they become also weak. That means the ciliary muscle also become weak. Okay, they automatically lose their capacity to actually contract and relax their muscles. Okay, they also, that means what we can say, they not become able to actually modify their focal lengths. Okay, they get the images like some kind of in their retina, some kind of milky and actually some kind of layers are there. That is nothing but also known as a cataract effect. Okay, once it actually occur, you are going to get some kind of blurry images. Okay, and that can be also cured using the help of some kind of surgery. That surgery is known as the what? Cataract surgery. Right now, this is kind of things that actually happens in case of the human eye. Okay, see, one thing you should know. How many sense organs do we have actually? 5 sense organs. Correct. So, all these sense organs makes us able to observe something, right? See, if I am just closing my eye, consider that I am just closing my eye. What is going to happen? We can actually sense something that yes, there is something with the help of our nose too. Okay, if someone is cooking some good food without observing, without actually opening our eye, what is going to say? We can just say that yes, something is actually cooking, like chicken, what do you say, fish, salmon, lots of things are there, right? Momos. Okay, we can say that. But what? We can just we have that much ability to a certain distance, only few meters. Okay, if someone is really cooking at 100-meter distance away from me, can I say that? No, because I'm not getting that much of smell, and our nose is not having that much of ability to smell to such distance. One thing, right? Secondly, if I'm again closing my eyes, you just close your eye, okay, just try to hear me. You can hear me, right? You can say that yes, sir is teaching something, right? Right, it's a fact. But tell me one thing: is it believed to a large amount of distance? No. If you just take your mobile to a certain distance and you just stay away from 100 meters away, if you are not using any kind of headphones or something else, okay, you're not going to hear anything, right? Again, if somebody touches me, okay, I will be able to say that yes, somebody is touching me. Okay, if I touch a hot tub or what actually metals I touch, what is going to happen? I can say yes, it is hot and I'm just touching something. Okay, if I touch a ice, I can say yes, it is ice. Okay, but there are lots of things are like, except ice, lots of things are there which is really cold as much of ice. Okay, if I say that it is ice, it is not going to happen, right? That means what? Though we have 5 sense of organs, right now, see, one more example we can take in case of tongue. Tongue is also one of the important sense organs to us. If somebody let me taste some sweets, I can say yeah, it is a sweet product. Okay, if somebody give me 2 such kind of sweets which having the same taste but different in sizes, shapes, okay, without opening our eyes, we can't say that. We can only say that yes, it's having a taste of sweet. But what we can actually got it from here, we have got that our all sense organs are actually necessary for us to get a proper information of an object. But among all of the 5 sense organs, our eye is the only thing which makes us to observe something to a very distinct level. Okay, that's why we can say that our eye is the most important sense organ for us. Okay, so we should be very much careful towards our eye. Okay, we do not actually expose our eye to some extra particles, dust particles, so we should be very much careful about that. Okay, whenever you ride a bicycle or ride a bike or something else, you should always cover your eye. Okay, this is the main fact. We actually understood how actually eye behave. Okay, what information we should actually carry about eyes. Okay, how our eyes is having capacity to actually that sense that focal length. Okay, sometimes it is able to actually increase its focal length, sometimes it is able to decrease its focal length depending on the situations. Okay, and depending on the image position. Right now, that's how it's eye behave. By the way, there's one question in your NCERT book. when I also think like that when I was in high school actually, why all animals and human being is having two eyes? Why? Why is it necessary? If I close one of my eye, even I can watch you. Okay. Even I close this eye, even I watch you. Why only need two eyes? Okay. See, you have this concept in your book. Okay. But before that, pause the video here. Okay. Pause the video here and give me your own opinion. What do you think? As I thought about that far point, that is, it should not be between infinity. It should be less than infinity. I told you now. As like that, you think yourself. Okay, just give me your own opinion, own idea why we be people having, or we the animals having two eyes. All right, what do you think? Just pause the video and answer me in my comment section. Okay, I need answers. I need answers from everyone. Okay, I need answer from everyone. Okay, I think you have given me the answer. So we the people having two eyes, or the animals actually having two eyes. What actually happens? You just consider my two eyes. Now, if I consider this as my eye, what is going to? I am just able to observe the things to this amount of extent. That means what? With the help of my two eyes, I am just able to observe my things, or that is surrounding in my surroundings, to this amount of angle. That is 180-degree angle. But the thing is, practical things should be there. Though it is written in your book that your field of view become 180-degree. Okay. But the thing is, we are just dealing with the distinct images, right? But whenever your angle is 180-degree, tell me one thing, is it possible to get the distinct image at the 180-degree? No, obviously not. See, my hand is here, right? I am just able to see that, yes, my hand is here, but I am not able to get a distinct image. If I move my eye like that, then I will be getting that, yes, I am getting my hand's image as a distinct way. Okay, we are only going to have this amount of area, okay, to where actually I am just able to see the objects clearly and distinct manner. That means what? This amount will be angle will be how much? It is almost 100 degrees, right? This amount of angle is 100 degrees. That means what you can say? To distinct image, okay, according to me, okay, this is a practical thing. I'm just doing practically, okay. Just do it by yourself too. You can do it by yourself. You can actually put your hand in this manner, and then you will be able to get distinct image only in this amount of angle, or angle of view. This is also known as that angle is known as the field of view, okay. If you just remove your hand like that, this is the total amount of field of view, or total amount of area till where you can just get a image, but not the distinct image. Okay, never think that you are going to get a distinct image. If you just look here and you are just going to get the image, you are not going to get distinct image. Okay, you are only going to get distinct image with your field of view in this amount of angle, and this angle is nothing but almost what? 100 degree. Okay, you have to write that what is your field of view. You have to write 180 degree, but according to me, that your field of view is, though it is 180 degree, to get a proper distinct image, your eye is going to have a field of view almost 100 degree. Okay, again it is in case of our human being, but in some case of animals, okay, they have eyes like that. They have a distance between their eyes quite high amount of distance, right? So what actually happens? With that case, their field of view increases. Okay, so it enables them to see their prey, right? So it helps their prey animals like tiger, some birds are there like eagles, okay? Lots of animals are there, or birds are there where having that much ability, okay? So this is the fact. How eye behaves, right? How ciliary muscles behave with the help of ciliary muscles, how you can actually sense the focal length, right? We all have discussed those things right now. So this is the things about the eye. Now we're going to discuss our next topic. This is the time actually right now where all the things are actually happening digitally. Now you are watching my video in a mobile, right? You have to watch movies and news in mobiles or TVs or some kind of laptop screen like that. Right now, what is actually happening? When you are just watching those kind of things in mobile, TV and laptop screen, okay, what is going to happen? Some harmful rays are also coming towards your eye. Okay, this is not the other way to watch my videos, to other videos like that, except mobile and TV and laptop, right? You have to watch it because this is the effect of the digitalization. Though it is good and necessary for us, it is again harmful for us too. Okay, it is going to harm our eyes. Okay, what is going to happen? It becomes disable your eye to actually construct the image or to change the focal length as it should actually do for a normal human eye. Okay, a normal human eye actually able with the help of his ciliary muscle right now to change his actually focal length where it is necessary. Okay, once your eye get affected with some kind of defects, okay, then its ability to actually modify its focal length decreases, right now. So these kind of things are actually happens. So depending on the defects, okay, you can actually classify all the defects in 3 categories. Okay, there are only 3. That means what you can say, there are 3 defects are there. First one is nothing but the myopia, which is also known as the nearsightedness. Okay, second one is nothing but the what? Hypermetropia, and nothing but the farsightedness. Okay, and the third one is nothing but presbyopia. Okay, we're going to discuss all of the 3 defects step by step. Our first defect is nothing but the myopia, which is also known as the nearsightedness. Okay, for a people who is having myopic eye or myopia, he is only able to see the nearby objects. Okay, now I'm just showing you 3 figures of a myopic eye. Okay, in case of myopia, what actually that figure 1 is actually meaning for you? Okay, it means that for a myopic eye, okay, that far point, okay, become less than infinity. Okay, that means what actually happens for a myopic eye, it is not possible to see object which is at infinity distance, right? That means what? Which is actually at a high amount of distance from your eye. Okay, it's not possible for a myopic eye. So what actually going to happen to form the image at the proper point at the retina, that far point should decrease to a certain point. Okay, that first O, okay, actually meaning for you that that should be a main position. Okay, it should be the main actually far point, but it is then reduced to the first O, second O, sorry. This is then reduced to the second O, and that means for a myopic eye, that far point should be there to get a proper image. Okay, if I increase the object distance to infinity, okay, you can see it in image 2 what is really happening, that images are going to get formed before retina. Okay, it is not possible for a myopic eye to construct the image at the retina. Once you are not able to form your image, okay, through your myopic eye at the retina, what is going to happen? We are going to get only the blurred image. Okay, see what actually happens. Some people, okay, when I was in doing master degree, I was a backbencher. Now I'm also a backbencher. When I'm just whichever I course pursue, actually I become a backbencher, and I love in backbenches. Okay, see some people, some students actually sit with me in my backbenches. What actually happens? They are not able to see the distance what is written in the board, because it is a quite distance, right? It is almost 20 to 30 meters away. If we are discussing something, if our teachers or professors are discussing something in a hall, that almost should be between 10 to 15 meters. Okay, if for that person, okay, having some kind of difficulty in observing that board, that means what? He is getting that images of that your letters that actually written in the board, some kind of blurry images. That means what? You have some kind of that far, it is not be able to actually construct the images in his eye that far objects, right? Simple fact, right? So this is the fact. That things will happen when we move to the front benches. What is going to happen? That far distance reduced, na? Right? That when he was in back benches, that should be the main distance. Okay, if you are just able for normal people, that is the far distance, right? If when he moved towards the front benches, that far distance reduced. Okay, that's the thing actually happening here. Okay, so that's how it is happened, and this can be actually happens. There are certain reasons. Okay, why this thing can be happen? There are all things, some kind of reasons are there. Okay, whenever that curvature of the lens, I am just telling you, this is the main high curvature, right? Whenever that curvature actually increases, what is going to happen? That lens is going to have shortest focal length or short focal length, right? I told you in case of the power of accommodation, right? A lens which is actually having less amount of thickness, right? That lens is going to have a long focal length, right? In this case, it is having a high amount of thickness because of high amount of curvature in this or excessive curvature. Right? This is the reason why a thick lens forming the image in the shortest point that we are seeing in the image 2, and this can be cured, okay, using a what? Concave lens. What is going to happen when you will actually use a concave lens? First, it is going to refract, okay, and their two rays going to move away from each other, but when they reach that natural or inbuilt convex lens that our eye is actually having, when it reaches, it then actually focus the two rays at the necessary point on the retina. That using that certain amount of lenses, you will become able to actually form the image at the retina. That's how using a concave lens or having a proper power of accommodation or proper power of focusing that actually images at retina or at a certain position, that is in their position, using that concave lens, you are going to cure, or you are just able to cure your myopic eye. Simple. You've understood them. Now we move towards our next defect, that is nothing but what? Presbyopia. See, presbyopia is completely reverse to that of the myopic eye. In case of myopic eye, what you have got, that person is not able to see the distant objects, right? But in case of the hypermetropic eye, what is going to happen? That person is not able to observe, okay, that objects which are kept at the near positions, right? Okay, what you have got from the power of accommodation? You have got that least distance should be 25 centimeter. Okay, I don't know we have observed or not, but I have actually observed in my life that people who has hypermetropic eye, they actually read the things like that. Okay, that means what? If this is the main 25 centimeter distance, they take the object here. That means what? Their least distance actually increases. That is more than 25 centimeter. For normal people, that least distance should be 25 centimeter. But for a hypermetropic eye, that least distance increases beyond 25 centimeter. Now you are just observing in the figure, you are just going to get three actually figures which is actually described in that hypermetropic eye, right? In the first image, okay, when that distance, okay, least distance will increase beyond 25 centimeter, that image is now actually forming what? At the proper retina position or at the proper position at the retina, okay? But in the second image now you are observing there, when that actually least distance is at now 25 centimeter, what is actually happening? That image is going to form at beyond actually retina, right? Simple fact, right? And this can defects actually occurs due to two reasons. One, when the focal length increases, and secondly, okay, when the eyeball becomes actually small. Once that eyeball becomes so small, what is going to happen? That diameter is going to reduce. Okay, consider that if it is the normal eyeball, okay, having 2.3 centimeter in diameter. Okay, I've just forgot to tell you that one normal eyeball is having a diameter of 2.3 centimeter. Okay, but for a hypermetropic eye, if that eyeball reduces, just consider this is the retina position. Okay, this is the normal actually position where the actually ray comes. If this is the retina for a normal eye with having a 2.3 centimeter in diameter, okay, again if I draw one more sphere which is of this size, what is going to happen? This radius will decrease. Consider this 1.3 centimeter. Okay, this is the main lens and this is the retina. See, what is the difference here? That retina position also decreases along with the decreasing diameter, right now? So what is going to happen? Here the image will form at the proper position after getting refracted, but here is going to what? Here the image is going to form like that, right now? That means what? The image is going to form beyond actually what? Beyond retina, right now? This is the meeting point here. So this is the behavior of a person's eye when they have some hypermetropic eye, and these things can be actually cured using a proper convex lens. Okay. What is going to happen when you use a proper convex lens? By the way, one thing should be clear. When you use a convex lens, that convex lens should have some thin lenses, okay? Then that ray will actually converge in a less amount of angle. But again, when they are going to reach our natural convex lens, it is going to decrease in a decent amount so that the image can be formed at the proper retina. Okay, that's how hypermetropic eye actually can be cured using the proper convex lens having proper power to actually converge the rays, right? And in case of the hypermetropic eye, we also got that we have to use proper concave lens, okay, having proper power to diverge the rays to our convex lens, inbuilt convex lens, then it is going to again converge to the certain point. Simple fact, you have understood, right? So these are the main effects of the hypermetropic and myopic eye. Again, there is one more defect, that is nothing but a presbyopic eye. Okay, see, presbyopia actually is nothing but a natural defect. It actually happens when people become old, right? It is not actually done by some kind of extra harmful effects like mobile, digitalisation, or not like that. It's a natural process of decaying your capacity to actually managing that focal length. In case of the presbyopia, what is actually happening? People actually loses capacity to observe the nearby objects. Using proper kind of convex lens, again, this kind of defects can also be cured. This is the main thing about the presbyopia. Again, some people is having some kind of defects like they are not able to see the nearby objects and they are not able to see distant objects too. Okay, that means what? In their eye, there is a presence of the defects of myopia and hypermetropia. Again, interesting one, right? So what actually happens in this case? The doctor prescribed that patient who is having that much of actually defects, which is actually hypermetropia and myopia is actually present. That person have to use a lens which is having a two property, like property of convex lens, property of the concave lens. That kind of lenses are known as bifocal lenses. Okay, that means they are having two kinds of focal lengths, one from the actually concave lens, other from the convex lens. The upper portion of that lens is for the concave lens to see the distance of the x, right? And the lower portion of that, okay, if this is a lens, okay, it is a middle portion, that upper portion is for concave, and this is the lower portion is for the convex, okay. For the upper portion enables us to see the distance of the x, right? And the lower portion or the bottom portion of the lens enables us to see the nearby objects, okay. That's why using a proper bifocal lens, a person who is actually having that myopia and hypermetropia simultaneously at a single amount of time, it can also be cured. That means with the advancements of the science, right, any disease or any defects can be actually cured, okay. So that's how actually eye actually behaving. So using that proper actually mechanism, we can actually still cure these things. Till now, we have actually understood the concepts that how actually eye behave, what are the main parts of the eye, right? Like vitreous humor, aqueous humor, retina, cornea, right? Eye pupil, iris, lots of things are there, right? That we have actually understood what are the properties of the iris, what are the properties of the cornea, right? So what are the properties of the eyeball, what are the properties of the pupil, lots of things we have discussed. Then we have discussed the power of accommodation, that means power of your eye to actually manage the focal length depending on the object's position, right? And managing that curvature of the lenses, eye lenses, and using that ciliary muscle. Then we have this simply, if you want to say, we can say that we have actually understood the concept of or behavior of the ciliary muscle. Okay, then we have actually understand the far point or the least distance of distinct vision, the far point of the distinct vision, right? In case of a normal eye. Then we just move towards our defects of that eye. That is nothing but what? Myopia, hypermetropia, and presbyopia. Okay. Till now, in this class, we have discussed these things. In the next video, in the next class, we are going to discuss the further parts. See, in a single video, as I told you in the earlier part of my video, it's not actually good or necessary to discuss all the things in a single video. Okay. If I do that, I have to make a long video, like 2 to 3 hours. But I don't know to do that. Okay. It is good if I make a video proper amount, like below 60 minutes. Is going to be good for you, right? Till then, keep yourself healthy, keep your eyes safe, okay? If your eyes is not going to be safe, you're not going to watch my videos. So I'm not going to like that. I'll feel bad very, right? Since you are now mature enough, just keep your safe your eye, okay? So in the next video, I'm going to meet you again. But before that, watch the video again because this lesson is properly based on concept. There is not going to be any kind of mathematical problem. Though 1, 2, or 2, 3 problems are going to be there relating to that of the focal length, okay? So these are simple problem, but main concept will be from the concept. So try to gain the concept first, then you will be able to understand anything. So as I told you in the earlier part of my video, don't skip this video, okay? If you have actually skipped that thing, this is my advice for you. So just again watch the video properly. Don't skip it, okay? By the way, if you just like my video for whatsoever reason, just like the button, okay? Or hit the like button and subscribe to my channel again, okay? So it's gonna give me some kind of actually encouragement, and that encouragement is necessary to make lots of videos, right? Okay, so this is the thing. I will meet you in the next video. Till then, bye bye.